Next, we have seen molecule ethane. Next molecule we are seeing is butane. Butane has how many carbons? 4. Now, in general, we write butane like this. So far, whenever we see nomenclature or anywhere, we have written butane, 4 carbon atoms. But in reality, I always tell what is the most important thing you have to think of related to carbon atoms is as tetrahedral structure. Will all the 4 atoms be in a straight line?
No.
They will be at an angle. Each carbon atom, CCC angle, what is the value? 109,
28 minutes.
So that is why we represent in a zigzag pattern. So now the black ones are carbon atoms. So you can see ignore the hydrogens, white ones are hydrogens. So this is the zigzag pattern. Can you see that?
Yes.
So this pattern indicates that this angle is 109, this angle is 109. So this is the structure of butane. Anybody who is thinking anything else or they are in straight line, get to the terms that it is in this pattern, that is butane molecule. Now, what we are interested is in conformations that are possible. That too, what conformations? We can think of conformations between other atoms, but now I want you to think of the conformations between C1, C2 and C3 carbon atoms. Now, label the 4 carbon atoms. One is C1, C2, C3, C4. Now I want you to think of the conformations between C2 and C3. What? Like ethane, we had 2 carbon atoms, we are seeing from one view. So these 2 carbon atoms, if it is ethane, instead of this carbon there is a CH3 group. Instead of this carbon there is a CH3 group. That is the only difference of butane versus ethane. Now, these 2 carbon atoms that you are seeing here are these 2 carbon atoms. To this carbon atom there is a methyl attached, and that is to this carbon atom there is a methyl attached. To this carbon atom there is one more methyl, that is to this carbon atom there is methyl. Can you see it that way? Yes. Now I want you to see the Sawhorse projection of this. What I am doing? I am putting both the methyls up. Can you see both the methyls up? Our bond of interest is C to C3. Both the methyls up. Can you see 2 hydrogens are towards you?
Yes, sir.
2 hydrogens are away from you. Is that clear? 2 hydrogens away from you. Plane of the paper. Methyls in the plane of the paper. Point clear? That is the methyls in the plane of the paper. This representation is this representation. Generally we represent like this. Always we don't represent the wedges. Okay, we can use both of it. It's for our convenience. Now Newman projection to this. We are seeing it in this way. What is Newman projection? You are seeing in this way. So this becomes the C2 carbon atom. That C2 carbon atom becomes the dot. C3 carbon atom becomes the circle. Is that point very clear? I am repeating it. C2 carbon atom becomes the dot. C3 carbon atom becomes the circle. On C2 carbon atom at the top, what is there? That is the methyl. Hydrogen, hydrogen. Hydrogen, hydrogen. On C3 also methyl. Hydrogen, hydrogen. That is the eclipsed form. How should the staggered form be? Angle between the methyl groups 180. So one methyl up, behind carbon atom methyl down. Automatically what happens to the position of hydrogen? The molecule remaining whole group is rotating. Remaining 2 hydrogens will become in between. They look from sideways, they will peep. That is this hydrogen and this hydrogen. Is the structure versus the projection clear?
Yes.
Any doubt, ask me. Clear? Right. Now one question to all of you. Apart from these 2, ignore skew. Can I have any other regular structure? Regular rotational isomer?
Other 2 carbons.
I only want rotation between 2 and 3. C2 and C3 are only forming the projection. I'll show it. Is this staggered?
Yes, sir.
Is this eclipsed?
Eclipsed.
Don't agree with everything. Is this eclipsed or not?
No.
Is this staggered?
No.
Then what is this?
Skew.
I said not skew. Skew is any non-regular angle. Here, I want you to see the view. This methyl group is exactly behind this hydrogen. This hydrogen is behind hydrogen. This hydrogen eclipses the methyl. So all the 3 groups are eclipsing 3 groups. Yes or no?
Yes, sir.
All the three groups previously present on the first carbon atom or the front carbon atom are exactly eclipsing or blocking the remaining three groups. Yes or no? Is that clear? Everybody can see?
Yes, sir.
But only difference is methyl is not exactly eclipsing methyl. That's the difference. This is also eclipsed, but not perfectly eclipsed.
So skew.
Perfect. That's the term I'll use. I'll use
Partial
partially
eclipsed.
eclipsed. I'll take the first carbon atom. This is the methyl, hydrogen, hydrogen. On the second carbon atom, behind the hydrogen there is a methyl. Behind the methyl there is a hydrogen. One of the hydrogen has hydrogen. This is also eclipsed, but not perfectly eclipsed because methyl is not eclipsing the methyl. So this one I am calling it partially eclipsed. Can I have any other such regular structure which is not skew? Think of it. Any other regular structure which is not skew? Okay, think in lines of eclipsed. Now from eclipsed I have moved to staggered.
Staggered.
In this staggered, methyl is exactly opposite to methyl, 180 angle. I can have one more staggered where it is methyl is not exactly
Yes.
anti to methyl.
So
Methyl is not exactly opposite to methyl on both the carbon atoms. But this is staggered. Is it understood? It is different from the original staggered that we have drawn.
Yes.
We have a name for this. The name of this molecule is gauche form. So how do I represent? You all can guide me in drawing the structure. First, a dot.
Circle.
H3.
Circle.
Now a
Circle.
circle. Where should I draw the methyl?
Beside.
the second.
Yeah.
Here.
Yes.
That's what you are seeing, right?
Yes.
Good. Where should I draw the hydrogen?
Yes.
Where should I draw the hydrogen?
Between the hydrogen.
So this hydrogen is this hydrogen. This methyl is this methyl. This hydrogen is this hydrogen. This whole CH3 is this. This hydrogen is this. This hydrogen is this. Is that clear?
Yes, sir.
So that is gauche form. So again we have four forms. Anything in between this is skew. Ignore about skew for a while. So I have to tell the dihedral angles. Theta value here is 0. Agreed? Theta value in the gauche form.
60 degrees.
Theta value here in the staggered form.
180 degrees.
So these are the conformations of butane. We can write in that order. Okay. In the earlier part, we have written anti here. So that this is the anti one. This is the perfectly eclipsed one. Just for clarity, I have written anti here. So the staggered form, if it is perfectly staggered, that is the methyl and methyl are opposite, then it is anti form. You can call it anti-staggered or just call anti form. Methyl exactly behind methyl, that is perfectly eclipsed form. This is staggered form but not perfectly staggered. Methyl and methyl are not opposite to each other, so this is gauche form. Here this is eclipsed but methyl is not eclipsing methyl, so it is partially eclipsed. So that is the clarity on all the four forms. Now we'll speak about the energies of all the forms. So how to decide the energies? Energy between different conformers is because of the repulsions between the molecules. Now, so I'll start with ethane. This is the energy profile of ethane. This is the energy profile of butane. Earlier we spoke about the main two conformers of ethane. The first conformer of ethane is this one, which is eclipsed form. The second conformer of ethane is staggered form. So in eclipsed form, I want you to observe that there is heavy repulsion between these two molecules. These two hydrogen atoms, there is heavy repulsion. In staggered form, behind this hydrogen there is no hydrogen, less repulsion. So there is low possibility of repulsion in staggered, high possibility of repulsion in eclipsed. If repulsion is more, energy will be more. If energy is more, stability will be less.
Yes.
So repulsion is more in which case? Eclipsed or staggered?
Eclipse.
Eclipsed repulsion is more. So if eclipsed repulsion is more, less stability in case of eclipsed. So that is why the order of energy is eclipsed is least stable. This is the stability order. Most stable will be staggered. Any other value, intermediate value of repulsions, intermediate stability, any other value is the stability of this group. So most stable, this is the stability order I am repeating, most stable is staggered, least stable is eclipsed. Energy order of ethane is clear. So this is the graph where in this direction you are representing the angle, torsional angle, dihedral angle. In this direction you are representing the energy. More energy for eclipsed, least energy for staggered. Any dot in between will be skewed. Is that clear? So staggered is at 180 degree angle. You can repeat the angles like that. Now comes the question of butane. So again in butane, first I have the eclipsed form. You can see the eclipsed form. So both the methyls are perfectly repelling each other. So repulsion is highest. Automatically energy will be, repulsion is more, energy will be more. Then comes stability,
Less.
least stable. So I should write eclipsed as least stable. I have written the eclipsed as least stable. This is the energy order. Eclipsed, least stable. What is the dihedral angle? 0.
Zero.
Next comes gauche form, which we have written here.
Yes.
So in gauche form, this is gauche form. Even in gauche form, there are repulsions between the methyl groups.
Yes, sir.
Okay. So in gauche form also, repulsions are more, energy is more, stability is less. So see about gauche form like that. We have one more eclipsed form, which is partially eclipsed. That is this form. In this, repulsions are there. Methyl is repelling hydrogen, this methyl is repelling hydrogen.
Different.
Even in this case, repulsions are more. So this is the next least stable one. So this is partially eclipsed. Now what is the angle between the methyl groups?
120 degree.
This angle,
120.
this methyl versus this methyl. This is like this is like this.
120
degree.
degree.
This partially eclipsed is this one. 120 angle. So that is why that is next in terms of energy. After this comes gauche form. In gauche form, we have the angle like this. So there is no eclipsion. That itself is a better thing. There is nothing behind one atom. So behind this methyl there is nothing. Behind this methyl there is nothing. So repulsions are in a way minimized already. Bond angle between this methyl and this methyl is
60 degree.
60 degree. So that is gauche form. So 60 degree bond angle, very less repulsions. So stability is considerably more. That is gauche form. Next comes anti-form. In anti-form, the angle is 180.
180.
Once it is 180, least repulsion, methyl is perfectly away from the other methyl. So it is most stable. So most stable form is anti-form. You can continue the loop. Now see this. I'll just flow with the graph. Eclipsed. Then comes gauche. 60. Then comes partially eclipsed. 120.
120.
Then comes anti.
180.
180. Then if I continue the rotation,
Partial.
then it is partially eclipsed. Can you see partially eclipsed now?
Yes, sir.
So it is 240. Then again I am rotating. Then
300.
comes gauche form. 300. Then again completing the rotation, 360. Eclipsed form. Is the energy order and the type of dihedral angle clear?
Yes, sir.
So this is the stability order. You can make a note.